Hello Mathies, Gatos here. In this video we're going to look at how to do a question involving higher derivatives and implicit differentiation. So two concepts, one question, no extra charge for that. So let's begin with this one here. I want to find the second derivative of x cubed plus y cubed equals 5. So I'm going to do some implicit differentiation here. So I want to do the derivative with respect to x of x cubed plus y cubed equals 5. So the derivative with respect to x of x cubed is 3x squared because the derivative of x is just 1. Plus the derivative of y cubed with respect to x, 3y squared, y prime, equals the derivative of 5 is 0. So I'm going to divide everything by 3 because it's an equation and I see that that's a common factor. So I'm left with x squared plus y squared y prime equals 0. So before I can do my second derivative, I have to isolate my first derivative. So I will subtract x squared from both sides. And then I will divide both sides by y squared. So y prime, the first derivative, is negative x squared over y squared. So I have a quotient. So I'm going to use quotient rule. So using quotient rule, let's just write that out. I have low d high minus high d low, draw a line and square below. So let's just identify what we have. We have our low function, which is y squared, and dl, derivative of the low, is going to be 2y y prime. Now my high function is negative x squared, and dh, derivative of the high, is going to be negative 2x. So let's put that all together into the formula. So y double prime is going to be low d high minus high d low. So multiplied by 2y y prime, draw a line and square below. So y squared squared. Okay, let's tidy this up a little bit. So I'm going to have a negative 2x y squared, and then here two negatives make a positive, and I'm going to have 2x squared y y prime all over y exponent 4. Okay, so we have what y prime is. See what y prime is? It's negative x squared over y squared. So I'm just going to simply replace that with the y prime that I have right there. So let's look at what that would look like. I'm going to have y double prime is equal to negative 2xy squared plus 2x squared y times y prime, which we know is negative x squared over y squared, all over y exponent 4. Okay, so let's simplify the top a little bit more. So I have negative 2xy squared, and then a positive and a negative is a negative, so I'm going to have 2x exponent 4, 2 plus 2 is 4, y over y squared, all over y exponent 4. So simplifying my fraction, I have a y divided by a y squared, which is just a y on the bottom. So because I have a fraction over fraction, what I want to do is multiply my entire numerator by y, and to be fair, multiply my denominator by y as well. I haven't changed the question because y over y is just 1. So distributing the y inside the brackets, I'll have negative 2xy cubed minus, now distributing it here, the y's cancel, so I have negative 2x exponent 4 all over y exponent 5. So let's keep on going. In the numerator, I am going to take out a GCF of negative 2x. So negative 2x divided by negative 2x is gone. I'm left with just y cubed. And then negative 2 divided by negative 2 is gone. And x to the 4 divided by x is 4 take away 1, which is 3, all over y exponent 5. Now that should look familiar. Y cubed plus x cubed. If I go all the way up here, that's what we started with. And what was x cubed plus y cubed? Well, it was simply just 5. So I'll make another substitution here. That's just 5. So my second derivative is just going to be negative 10x all over y exponent 5. So we do two substitutions, one for the first derivative, and then if it works out nicely, which it should, you're also going to substitute in the original equation. So hopefully that made sense. To end this question, I have a little question for you guys, though. I want to know, if I can get to the next page here, what is the derivative of Amazon with respect to the cost of shipping? Derivative of Amazon with respect to the cost of shipping? Well, something that I hold very near and dear to my heart, Amazon Prime. So I hope that this video helped, and I do look forward to seeing you for the next one.